let's go to section 7.3. Okay, so the first thing that we're going to talk about here is the order of a matrix. Now, you need to understand that I might ask you for the order, I might ask you for the size, I might ask you for the dimension, and they all mean the same thing. But if you only memorize what one of those words means, you'll be clueless when I ask you one of the other two words. Okay, so order, size, dimension, they're all the same thing. We're always going to list these as the number of rows by the number of columns. Now, I always have students who are like, oh, I forget which ones are rows and which ones are columns. I want you to think about this. When you drive by a house, and this house has a huge front porch with these big white things on the front porch, what are those called? They're called columns. Columns go up and down. Rows are the other ones. Okay, so that's how I remember it. I picture in my mind the big white things that are in front of the house, okay, attached to the house. So let's do the easy one first. That's really quite ugly. How many columns are there? 4. How many rows are there? So we're going to have the number of rows by the number of columns. We will write that as a 3 by 4. 3 by 4. Number of rows by the number of columns. And that X means by, you know, like if you have to lay carpet down in your bedroom, whoever's measuring your bedroom is going to say, he's got a 10 by 12 room, meaning 10 foot by 12 foot. Okay, so that's what that by means. So then let's go to the other one. What's the dimension of this guy? Yeah, it's a 1 by 4. Okay. An augmented matrix. This is where I can take a system of equations. Oh my goodness. Have you ever seen a system this big before? Aren't you glad I didn't make you solve this one by substitution or elimination? Because that would be, right? But with matrices, I'm going to find that solving a system that's this big isn't that bad. So matrices make solving systems much simpler. And so what I'm going to do is I'm going to make a matrix. If you just had to guess, how many rows do you think this matrix is going to have? 3. My first column is going to be my X column. My next column will be my Y column, then my Z column, then my constant column. No variables are written. No variables are written, okay? If it's in the first column, I automatically know these are my variables for X, all right? So let's read the first row. What would the first row look like? Okay. Somebody else, what would the second row look like? 1, sorry, and 7. And what would the third row look like? Now, to make it augmented, we're gonna draw a bar between the variable side and the constant side. Okay, and just simply because these are in the first column, I know that they're all X's. The second column, I know that they're all Y's. I don't need my variable there to show that. That's how it's always gonna be, okay? Look at this guy. Same directions. Let's take the system of equations and write it as an augmented matrix. Now, how many rows do you think there's gonna be in this one? 3, okay. So I'm going to go ahead and put in my equal sign bar. Okay, this one's funky looking, right? Start at the bottom. What would the bottom row look like? And why are you putting a 0 in? Because there's no Y, but you have to have a placeholder. You can't have any blank spots in a matrix, okay? So you've got to have a placeholder there. You said 6 for the other side. Okay, how about the middle row? Somebody else? Very good. And what about the top row? Yep. So always having then a placeholder for every single spot, for every single variable, even when I don't have that variable. All right, now let's go backwards. Let's go backwards. So now I have an augmented matrix. Let's turn it into a system of equations. Okay, so what would the first equation look like? X equals 4. What would the middle equation look like? Y equals 2. And what would the third equation look like? Z equals 3. Now those are 3 pretty easy equations, aren't they? And if I take what I learned from the video, what kind of form is that matrix written as? Close. Yeah, reduced row echelon form. What was the requirements for reduced row echelon form? Very good. I had to have zeros above and below the diagonal, and the diagonal was only once. Now, you know why reduced row echelon is really, really pretty? Because it solves it for us. If I have reduced row echelon form, I immediately know what my X is, I know what my Y is, I know what my Z is. I don't even have to do any solving. Okay? So that's why, oh, wait, reduced row echelon form. What's the letters for that? RREF. Where have I seen that before? It's one of the ways to solve systems of equations. So if I can get it into RREF, reduce row echelon form, solving this is a breeze. It's a cinch. Okay. All right. Let's talk a little bit about the difference between row echelon versus reduced row echelon. Row is where I only have to have zeros underneath. Reduced row is where I have zeros above and below. Now, let's use one of these. Number 5. When you look at the matrix, what kind of form is this? Row echelon, that and the directions tell you that. Okay, so it's in row echelon. And it says use back substitution to solve. No calculators on this. Okay, use back substitution to solve. Now look at your 3 rows, which represent 3 equations. Which is the prettiest equation? The bottom one. So let's write it. What's it say? Z equals 2. Well, okay, I've got 1/3 of this solved. Okay, what's the next prettiest equation? The middle one, right? So let's write out what that equation says. What does that equation say? Y minus 3z equals 1. Oh, but wait. What do I know now? Yeah, I know my z value, and if I know my z value, I can plug it in for my z over here. So let's do a little bit of work. So we've got y minus 3z, but z is 2, equals 1. So what does y equal? 7. Okay, so I got 2 out of 3 solved. Now let's go up to the last equation, which was the ugliest of the 3. What does that equation look like? Okay. But what's cool now about that? Yeah, I know 2 of my variables. So let's plug those 2 variables in. We've got x minus 2y, which is now a 7, minus z, which is a 2, equals 0. So I've got x minus 14 minus 2 equals 0. So x is equal to what? 16. Now wait a second. This was a system of equations. Okay, because an augmented matrix is a system of equations. How are systems always supposed to be written? As a coordinate. This one does too. Only now instead of just an x and a y, I have an x, a y, and a z. Okay, so what's my solution then? Yeah. So again, for any generic system of equations, my answer should be written as a coordinate. Occasionally, I don't think I did one of these examples. Occasionally, can I just throw this out here because you'll run into it with my lab? Occasionally, you'll have something like this. Let me see if I can copy this. Duplicate. Oh, lovely. That's all I could duplicate. So let's see. We'll have a 1, a -2, a 1, a 0, a 0, a 1, a -3, a 1, a 0, a 0, a 0, and a 2. What are your thoughts on this? Yeah, Z has no solution. In fact, I cannot find a solution, period. It's not just the Z piece that I can't find a solution. What does the last equation essentially say?
That the others can be solved.
Possibly, but just tell me what the last equation would be if you wrote it as an equation. 0 equals 2. When was the last time 0 equaled 2? Never. Okay, this is a false statement. I cannot solve anything. For the record, I alluded this earlier, but let me say it specifically now. If I have 2 unknowns, I've got to have 2 equations. If I have 3 unknowns, I've got to have 3 equations. If I have 9 unknowns, I've got to have 9 equations. Don't worry, we won't ever get that big. Okay? But my point is, I only have 2 full equations, but I have 3 variables. So I cannot solve this any further because of the fact that I have a false statement and I don't have enough equations to solve for the number of unknowns that I have. Okay? So we would say here that there's no solutions. There's no solutions. All right? Okay, use a calculator. You guys have your calculators out? I've given you this how-to list, because, okay, on the test, you will not have this how-to list. You have to learn this, okay, but the more you do it, the more you will learn it. So let's look at the number 1. It doesn't say anything about typing into the calculator for number 1. What does it say to do for number 1? Write the matrix as an augmented matrix. So that's the first thing that we're gonna do. We need to take our system and we need to write it as a matrix. So what would this look like as an augmented matrix? First row. Okay. Second row. 2, 1, -2. We'll put our augmented bar in there. All right, so that takes care of number 1. Now let's go to number 2. Find the X, it's actually the X inverse button. Find the X inverse button. X -1 button, X to the -1st power button, whatever you want to call it. What's right up above that? Matrix. Okay, so you want to push second matrix, and I want you to notice something. Do you see across the top you have 3 options? What are the 3 options across the top? What's the first option? Names. The middle option? Math. And the last option? Edit. All right, can you do me a favor? Can you arrow between the names column and the edit column? And tell me what, do you have an idea? That's probably not gonna work. I got it, you have to borrow mine today. Because this is too important. You won't be able to do it on your phone. When you arrow between the name column and the edit column, what do they look like to you? When you compare them? They look exactly the same. So why would I have 2 columns that are identical to each other? So listen carefully. When I want to type in a new matrix, or when I want to edit an old matrix that's already in there, I'm going to use the edit column. If I actually want to use a matrix, I use the name column. Okay, so even though they look identical, they have two different jobs to do. So go over to the edit column. And let's choose a letter for the matrix. How about A? Since it's our first matrix ever. Are there any matrices in yours, Becca? In my calculator? That's fine. So just go into A because you can write right on top of the old one. Okay? Let's go into A. Go ahead and push enter here. And you'll notice that your cursor is blinking on the size, the order, the dimensions. What is the order of this matrix that we have here? It's a 2 by 3. So go ahead and type in 2, enter, 3, enter, and you'll notice that your matrix on the screen opens up to a 2 by 3. Now your cursor is blinking on the first entry. So you want to enter by rows. So go ahead, you're going to do 1, enter, 2, enter, 5, enter. It'll bump you to the next row, 2, enter, 1, enter, -2, enter. Don't forget to enter after the last one. All right, so are you with me? You could go ahead of me, but there's some explaining going on. So we entered our matrix completely. That was step number 5. What am I telling you to do next in step number 6? Yeah, I know it says second mode, but what am I telling you to do? Quit, get out of there, get back to the home screen. This is a really big deal, and if you mess up, it's probably gonna be right here that you do it. Okay, so you've got to get back to the home screen. Okay, look at number 7. Doesn't number 7 look identical to number 2? So where am I taking you in step number 7? Back to the matrix menu. Okay, so go back to the, oh wait, does the matrix menu look a little different now? Yeah, you got something in there, don't you? Okay, so what we want to do is we want to take the matrix that we've got in the calculator and we want to do our REF on this matrix because our REF is a good way to solve. All right, so you have to go under the math column in the middle. Go to the math column. And you want to go down, 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 keep going, keep going. What are you looking for? RREF. And you've got 2 of them. You've got an REF and you have an RREF. Make sure you go to the RREF. Okay? You can push enter there, but then you have to tell the calculator which matrix you want to get RREF of. So this is where you're going to use the name column. So second matrix. Now you're using the name column. You all saved it as matrix A, so just choose enter on matrix A. Your home screen says RREF matrix A. Push enter. Now your calculator is going to spit out a new matrix. When I'm looking at your work, I'm looking for the original matrix. I'm looking for the new RREF matrix. And then I'm looking for your solution. Okay, so what is the new RREF matrix? And by the way, I didn't do my, Becca has my calculator. I didn't do mine on my calculator, but I can tell you right now, I'm going to have a 1001 on that side because that's what RREF is. What's my constant column look like? -3 and 4. Is that what you said? Okay. So I've got my old augmented matrix. I have my new RREF matrix, and now I need to write down what's my solution. -3, 4. Method number 4 of solving systems of equations. Now there's only 2 minutes. Do we think that we can go ahead and do number 7? Okay. Try it. If we run out of time, I'll tell you what I'll do. I'll give you the answer so you can try it on your own. What are you writing out first? Yeah, we need my augmented matrix.
So 4, 2, -3, 6, 1, -4, 1, -4, and -1, 0, 2, 2.
What's the dimension of this guy?
It's a 3 by 4.
And you should get an augmented matrix where the last column is 2, 2, 2. All right, guys, I will see you on Thursday